I need to clarify a bit. When I talk about a parse tree, I'm talking about the derivation of a single string. Okay, so you're talking about the parse tree where the root node is your start symbol, and all the leaves at the bottom, the leaves, that's your string. Okay, so you're not talking about multiple strings. You're just talking about the parse tree of one string. Okay, all right. So any string S that belongs to your language A, it'll have and it's generated by a grammar G, and therefore that string, little s, will have a parse tree that you can create from the grammar. So it starts with big S, the start variable, and you work down until you have a string that's totally consisting of terminal symbols. That's your string. You have derived it. Okay. Now we've assumed that S is long, and therefore the parse tree will be long in depth. It will have great depth, and therefore any path from the root node to a leaf, let's say, will be long. Okay, so it's on a long path. So because it's with the length of the string S, so double bar S is long, there will be a path at least that's very long in this derivation, in this parse tree. So that there will be a long path. Okay. Now on that path, this long path, okay, there will be a variable symbol called R that repeats. There will be a repeat as you go down the path from the root node to the leaf, to the terminal symbol. Along that long path, there will be at least there'll be a variable that is repeated. And you may ask, well, why? Well, this is the outline of the proof, right? You need to go to the detailed proof to prove that that's the case. But this is just sort of an overview. So by using the ideas of pigeonhole principle that we used before in the previous proof of a pumping lemma, we'll do something similar. And we'll actually prove that that's the case. That as you go down this long path in the derivation, the parse tree of the string, the single string we're talking about, S, as you go down that path, you will come across, at least in one instance, one case, you'll see a variable that gets repeated. Okay? That has to be, and we'll prove that that's the case. All right? Now call that variable that is repeated, big R for repeat, I guess. Okay? And it has to exist because of a pigeonhole type argument, and we'll do that in the detail proof starting next square. Okay. Now this repetition, well, let's say it occurs twice. Let's say a particular long path, and at 2 points in the various steps in the path. Let's say the R occurs twice. Now we can talk about figures. So here's your let's say your root node with your starting symbol. I've always got it with T. So down, step by step, substitution rule by substitution rule, various steps, until eventually you get to your string S, little s, which you write this way. And a particular path that you took, that ... so you have it here, like where it stops here, you have a particular terminal symbol, and above that, one step above that would be a variable Has to be, right? You can't have a, because once you get a terminal symbol, well, it terminates, that branch terminates. So above this, you'll have a, now it's one of the long paths, remember? Not a very short one where it sort of terminates way up here somewhere, but say it's a very long one. And so so you have terminal, 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 and that's a terminal. Sorry. Variable, 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 variable R, variable, variable, variable R, variable, right to the top. So all the symbols above this above the terminal, they will be variables, and two of them are the same. There has to be, and we'll show that in the proof. Okay, so now here's the essence of the proof. You see the little subtree, a sub-parse tree that I've put in black here. That parse tree comes from this variable R. Okay, and this bigger triangle here, this triangle here, that's a subtree that comes from this R. Okay. Well, here's the idea now, and this is the essence of the proof. Usually, when you're trying to dream up a proof, you'll have some clear idea, the essential, the core, the heart of the proof. And so here's the main idea now, and the rest are sort of details. Okay. Take this subtree here, this little one, and this subtree, this bigger one. Now, cut out the bigger one, throw it away, and replace it by the smaller subtree, and put it up here. So this this little subtree would be now up here. Okay. Now that would still give you a legal string. Why? Because the grammar can derive either this big one from this R, this variable, right? So grammar substitutes. Grammar works with variables, but it can also work with this one. So if you throw away this bigger subtree, subparse tree, and you replace it by this smaller subparse tree, and put this subtree like here, this parse tree is still legitimate. So it's allowed. That could be a legitimate string found by the grammar. Why? Well, because this X here, if you like, that sub-string was found by the grammar starting from the variable R. Okay? Now we could go the other way. Now in this case, take this. Take this small sub-parse tree and cut it up and throw it away. Okay. So you've now got a sort of little hole here, imagine. And now take this bigger subtree, the whole thing, including this part, this whole thing, and put this subparse tree starting here, because these two R's are the same. Okay, so I can put this subparse tree here, and I'll get this sort of thing. All right. You're starting to click now. You're starting to see where this is going. Well, now you can see this string here, your S. This is your S here. That's been derived from your grammar. You can see it's in like 5 parts. This part here, call it X. That's the substring that you generated from R. This R, the second one, the second occurrence of R, the repeat variable, yeah. And but this part, and so then you look at this subtree, and this part here, call that V, and call this part Y. Okay, and then the part that lies outside this subtree, vxy, call that part u and that part z. So you can see where you're getting your 5 parts from. This subtree parse tree generated by this r, and this smaller subtree generated by this r, but they're the same r. So you can swap them around. Now let's see, when you take this subparse tree, smaller, and throw it away, and replace it by this larger one, which includes this little one here, this larger one, well, you get something like this. Well, then can you see you've got a v here, which is this v here. But what this v here pre-exists, right? This v here is just the same as that. But you've now taken this bigger one and put it, this apex of the triangle here, you now put it here. So you now got this triangle like this. But this triangle, if you like, this subtree, it has a v, the same v. And has this region here, which this substring y, which is the same as that. Well, you can see, so now we've got a string that belongs to the language, because you can keep generating it from these r's, and so now you've got a string u, v, v, x, y, y, z. Now we can keep going. We could create a string that's u, v, 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 x, y, 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 z. How to do that? Well, you take this little subtree here, throw it away, and replace it by this larger subparse tree. Okay? So then you'd get 3 v's and 3 y's and so on. Okay? Get the idea? Alright, well we've dealt with that case. Now here your v and your y are missing. Oh, you can't see it. I thought that was